Okay, so morning everyone. I don't know if it's good morning, if it's good afternoon, but I'm Luis Duarte. I'm here to show you how they used to say now an opinionated view about how to bootstrap an application using microservices. I'm not going to go into very detail on how JAX-RS works, on how Spring MVC works, on how Java works. I'm going to assume that all of us can develop a web application, so I'm not going to go into very detail on that. So let me just switch to the presenter view. Forgot to hit resume. Okay, so a little bit about me. My name, you already know. I'm a software engineer at Anubis Networks, recently acquired by BitSight, the world leader in security ratings. I have a bachelor's degree from ISEL, and you have my Twitter and GitHub handle, just in case you have any questions you want to ask later, you don't have the opportunity to do here in this talk. So, why are microservices good? Who remembers the days that you had to be awake all night on Sundays when you have to be just present because the deployment was just going, the deployment was going on, and if something went bad, you need to be there to roll back, to apply hotfixes. So this is the main thing I like about microservices. For example, at BitSight, we do like 20 deployments a day into production. They require a bit of discipline. They need to be small, self-contained, easily reversible. This is the main thing I like about microservices. It allows you to have tech stack decoupling, which means you can have a service written in Java, you can have another written in Python, another written in Ruby. You can do it whatever you want. You can easily replace services. Imagine that you have, for example, a book service, which will be our showcase for today. Imagine that you have a book service and you want to create a book service v2. Okay, no problem. You just create a new container named book service v2 and put set the gateway, the web server, to redirect to that service instead. It's pretty easy to just switch off one, turn on another. And it's easily scalable. Docker, I forgot to mention, I'm going to assume we all know what Docker is. Docker allows us to easily scale our services, just spawn instances whenever we need them. And I'm going to also show some tools that will allow you to auto-scale so that the web server knows where the new services are. So the downside. Basically, what I put here on the downside, it's the fallacies of distributed computing. You're relying heavily on network I/O, and sometimes it goes bad, and there's no certain way of knowing if it was the client that did the request, or if it's something inside your microservice architecture, inside the network that went bad. You have some tools that will help you. For example, tracing. I know a tool, it's called Zipkin. It will generate a lot of I/O because what Zipkin does is every place where the request goes, the request is tagged with an ID, then it's reported to Zipkin. So you can make a tracing of where the request is going. So configuration, sorry, not following the configuration. With the microservice, you're probably, as your application scales, someday you'll end up with like 50 services. Who wants to change configuration and have to redeploy all the services all over again? You don't want to do that. You want to change, for example, in a central point, and your service will adapt to it. It should be reactive. And if the gateway fails, well, if something goes wrong, well, no service for anyone. I created a slide with some of the well-known services framework in Java. We're going to be using Spring Boot because personally I don't like Spring, but I think it offers too much out of the box if you're, for example, a startup that you need to focus on delivering new features. This is why I love the Spring universe. I compiled some platform as a service. You can either run your own or use the known service providers. The one I recommend for you to run, sorry, noise. The one I recommend you to run on is Kubernetes. For me, it's the most stable, the most most mature, the biggest community, and it's made by Google. But 99.9% sure, if you're creating your application and you're creating your startup, you're going to end up using a Elastic Container Service from Amazon. So let's go down to some architecture principles. At the end of the day, monoliths is what we have. In my opinion, scaling a monolith, it's a no-brainer. You just create another virtual machine, having JBoss on it, having the WAR files on it. They all share the same database, and you just have to update the web server to balance between all of these services. The bottleneck is typically on the database. This is okay. It's a good application. This is what most of startups do nowadays. They start with a monolith, typically a Ruby on Rails application. The problem is, when your business is scaling, Ruby on Rails just becomes, for example, too big. And you try to do small code modifications, and you can break the entire application. This is a problem with monoliths. When they become too complex, they just don't scale when your business is growing. So the microservices approach required the gateway to become a bit smarter, meaning it had to transform the request before going into the service. As you can see on this diagram, for example, book service, and we have two services, book service and an authentication service. They both have a database. They don't know that each other exists, and they don't know that each of them has a database. For example, the book service can be a Neo4j database, that can be a MySQL database, it can be anything. They all speak the same language, HTTP, typically. I took a quote I read some time ago, people telling SOA is dead and long live SOA, because essentially what microservice, the concept is it's been here around for all ages. For example, on big enterprises, you have enterprise application integrations, stuff like TIBCO, web methods. Essentially, the gateway will do the same. You have a service broker, you just distribute requests throughout all your microservices. The only difference is the microservices are more refined, are more smaller. Okay, I'm going to show you how to create a service with Spring Boot. You can either go to this URL or use IntelliJ Ultimate. I'll be using this just to take a shortcut. But if you go to this website, I can show you the website. See, you can easily create, it just pre-generates a Maven project or a Gradle. You choose the Spring Boot version. You can even choose your dependencies. It's pretty much, like I say, a no-brainer to create a service. So we go. I'm going to use Maven, for example, book service, camp.pixels.pickle book service. Okay, next, what we're going to want? We're going to want session. Where's the web? Web, and we're going to use Lombok. Okay, next. Okay, next. It's going to create the service for us. And it showed up on the screen. Takes a bit. Sorry for the delay. Blame JetBrains, not me. Okay, so you can see source main Java. Okay. Essentially, this is how you bootstrap a service with Spring Boot. Essentially, it's a Java minus jar, just executable jar with an embedded servlet container. You can choose Tomcat, Jetty, just like I said, in my opinion, offers too much out of the box. As you can see here, I can easily go in here. Let's add the dependence. Okay, it's not yet ready. Okay, and with this, By adding this, I just chose Jetty. It's like drop-in replacement. You can choose Jetty, Undertow, anything you want. So I'm going to close this for now. I already have a service. Come on. Okay. I never understood the Mac on this. Sorry about the confusion. Okay. Now, sorry, multiple screens. Sorry. We're going to focus on this, the book service. I already created a book service. Sorry, I'm just not used to do presentations on multiple screens. See, this is a book service. It's all annotations. It's pretty much a no-brainer. What I love about Spring Boot is that you can have a YAML configuration. And for example, this variable will be looked up into the environment variable, a Java property. It just gives you a layer of abstraction. You don't have to worry. It will look up automatically to where all the properties come from. So essentially, I created a book controller. It's a Spring MVC simple controller, which has books. I created a Docker image here for Nginx with our configuration, so we can reverse proxy. Never expose microservices directly to the outside. Always use the gateway for that. Now I'm going to show you how this works. So Maven package. I forgot to tell you something. Not this one. You should use a Maven plugin from Spotify that will just pick up your generated jar and will just put it on a Docker image. You just have to give him the entry point and some commands if you want, or run something. This is essentially how creating a service in Java is. It's going to be run like Java minus jar. And when you're creating the service, you just have to invoke it with environment variables. I'm going to show you the Docker Compose. See? I'm mapping the ports for the gateway, and and I'm injecting the property. It can be 80, it can be 80, 81. Okay, Maven package is done. So, let me just delete all the Docker image. Docker image is running, none running. Okay. First failure of the day. Sorry about that. It's creating the book, creating the web application. It's initializing Java minus jar in a Java container. Okay, it's up. We're going to localhost. Have the books. You have the Nginx reverse proxying to the microservice. In my opinion, this is a no-brainer. This is like I said before, it's been around here for ages. We just add some more granularity to it. Where is the? Here it is. Sorry. Okay, this is our current architecture. What we have. It's pretty simple. The stage 2. I'm going to create an authentication service. So after creating this, I should say I already have the code made, so to save us time. Do you guys see any problem here? Imagine on book service I had a protected resource for that user. How do I check authorization? This is one of the main concerns, authentication. I don't understand why this keeps showing up here. Okay, let's go to stage 2. See, created another application using Spring Boot. It has a boot configuration. The Nginx, the only thing I did was created the new configuration just to reverse proxy to that service, to the container name. So like I said in the beginning of this talk, I'm not going to go into very detail on how you implement this. It's just a simple web application. It can be Python, can be Ruby. I chose Java because, well, it's my main language, so like I say, I'm home with Java. So let's kill all running containers. Event package to generate the new image. I map /login for the authentication app and /books to the book app. Now, the book application, for example, it receives a cookie, a session cookie, and it goes like, okay, what do I do with this cookie? How do I know which user it is? Sorry, it takes a bit to come up. See, one is using 1.3.8, other using 1.4.0. So they're self-contained apps. No dependencies from each other. They both talk JSON. So, okay, they're up. Go to login, foo bar. Okay, I don't have the redirect on. But okay, now I'm in the books. Imagine I was in a protected resource. What do I do with the session cookie? This comes to my next topic, which is how do we share information between these services? Well, since book service doesn't know which database authentication service has, how do we do it? This in microservices. My opinionated view is Redis. Redis is a distributed cache system. Typically, I put, that will be further. Typically, I put all the session information in Redis, and the other servers should go get there in this stage. So why Redis? Because I think it's fast and resilient. It's like Memcached on steroids. It's key value stored. You can put a time to release on an expiration on all your entries. It can act as a message queue, which don't use the same as for storage and for message queue. Use a different instance for that. It's resilient, meaning if an instance goes down, it has a mode that when it comes back up, it comes with the same state. It has a very active community, which means a lot of minor releases, and this is good, a lot of bug fixing, and as a BSD license, which you can do anything with it. So this is the scenario that we're going to implement. There it goes again. I'm not going to show you. The code didn't change that much. We need to recreate the Docker containers. Sorry for keep you waiting. It's recreating the authentication service. The only difference is I'm using Spring Session, which is an abstraction with, it can abstract Redis, Hazelcast, and Gemfire, can abstract from all the key value stores. So, first of all, let's kill all the running containers. I recommend doing this in development. Sorry. I'm used to a big keyboard. Okay, see, Redis is up. Did you know that Twitter has around 105 gigabytes in a Redis cluster to manage sessions? This is why Redis is so good. They even created a proxy app to aggregate all those Redis clusters. It's awesome. Okay. Sorry, I need to clear the cookies so nothing goes wrong. So, okay, go to the login, authenticate again. I go to the book. And we have a problem. This is on purpose. This is not unexpected. The problem is the session is managed internally by the authentication app, by that JVM process. It's serialized through a JDK serializer. When this guy tries to deserialize, oh, I have no reference for this. This is going to take me to our next stage. I'm going to show you. But one of the things I want you to also notice about is that, okay, even if we had Redis to correctly deserialize that user, a problem would still come up. Imagine you had 100 microservices, and imagine for each request that it reaches, it's going to do a Redis request. You're going to overflow Redis with a lot of requests. For that, it's recommended to use a Json Web Token. How the Json Web Token works. The Json Web Token is none less than 2 JSONs and an HMAC signature, which basically we can have the principal in a JWT. When the request is invoked, if it goes into the authorization header as a bearer token, you already have all the principal information, and it's signed. If you verify that signature, it came from the authentication app, okay, you can trust it. This is, I put this slide intended because JSON Web Token, I see many applications exposing user information directly to the outside. My opinion, don't do that. Because, for example, imagine that you have on the principal, the principal object, you have permissions for that user. You have roles for that user. Okay, an attacker might see, oh, this guy has this role. It's a good path for the attacker to start reverse engineering your application. You're not going to want to do that. So you can pass a JSON Web Token to the outside, but only with reference data. If you just get IDs, okay, what do I do with this? And the best practice, this is how I'm going to show you in the next phase, is in the web server and the load balancer. The web server will just receive the cookie, will exchange for the JWT that's pre-generated it to Redis, and it will just put it in the authorization header. This is, in my opinion, the correct way to do it. You might argue, okay, that's going to overload the API gateway. Fine, but like I said, it's an opinion. You can always go to querying Redis all the time. For that, I'm going to replace Nginx with a more intelligent gateway, which is Kong. Kong is built on top of OpenResty, which is built on top of Nginx. OpenResty is nonetheless than Nginx with some, Nginx with support for Lua. You can just go to your Nginx configuration, just put a string with your Lua code, and okay, this is OpenResty. Kong is a very fresh, very new framework. It gives you a plugin development environment, gives you a set of an abstraction layer. It makes it easier for you to, will make it easier for you to develop plugins on it. It's still in its young stages, but it's on a good path. I'm announcing it here, so with the hope it can get more community contributions. So we are going to eliminate this dependency since we're not going to be needing this anymore. This will be the current scenario. Kong will fetch the JWT from the Redis, and we'll just put it in the authorization header. So I'm going to fast forward this because I believe this is a no-brainer. It's easy just to an hget to Redis. So the next thing is how do you scale your service? Okay, imagine you just launch new instances all the time on your service. How will the API gateway know what are the IPs? Like I said, imagine you have 100 microservices, each of them with 3 instances. It's like 300 IPs that you have. You're not going to restart the gateway every time something changes. It just won't happen. We have several solutions for this, which is we have Consul, we have Eureka from Netflix. By the way, Netflix has a very good open source solution for microservices. But in my opinion, they're just too developer-oriented, which if you're a developer, they're cool. But if you don't have a DevOps team that are also very good developers, it's a bit hard to manage. That's what I learned from my personal experience. Have Apache Zookeeper, which is, well, it's good, but it's old, it's outdated. And you have etcd from CoreOS team. Sorry, I was forgetting the name. So for this demo, I'll be using Consul. I believe that Consul offers you like Spring Boot offers you too much out of the box. It's the only one of the systems that has an integrated web UI, and it has you can query through a DNS interface. You can just do DNS queries to Consul with the services that are registered. It will just load balance the requests for you. It has a funny data center concept. I didn't understand it at first, but when I started exploring, it makes every sense. For example, imagine, for example, Netflix. Netflix has the United States server and the European servers. They have different shows on those servers. If you change your DNS to the United States, you'll see more shows on Netflix. But if they used Consul, they could see from what region your account is, and it would query to the correct data center. And even if you were in the United States, it would point to the European servers. This is a pretty interesting concept. It's, well, I showed this specific case, but it's interesting. It does also health checking. For example, in HTTP, the service is up. It will just poll by default the /health endpoint. If the service somehow fails, the DNS and HTTP for service discovery, it will just stop giving you that IP, the gateway, that IP. So this will be the final architecture. This is the basics. Okay, Kong picks up the session from Redis and performs service discovery on Consul to reach all the services. On local, you don't need to use Consul because Docker already has DNS discovery. But I prefer to have a much more similar environment with production. I advise you to do that. So, let's clear all the images. We need to recompile and crush the images that are created on the local Docker cache. And I created this run.sh script. I haven't put it yet on the source code, but I'm going to put it because some services, one of the limitations in Docker is that you can put the depends on, but it's not very well managed. Okay, for example, you have a service and a database, and you want to ensure the database is running. If you boot up the two at the same time, when the service is connecting to the database, probably it will get the connection timeout. See, I'm putting Consul up and Kong database, and I'm waiting 30 seconds just to make sure they're up. It's going to take a bit of time. Meanwhile, I can show you the code. Can you guys see the font? Do you want me to increase the font a bit? Okay, so I've modified. Sorry, this is the utility class I create for both. See, it has all the JWT handling. I'm not going to go into very detail on this. I added this, the Kong Docker file. You have a tool called Consul template, which I used for the Kong image. Kong image in the Docker file uses DNS mask for service discovery. So it doesn't yet support SRV record lookup through the DNS. So the workaround is HashiCorp also makes Consul template available, which is a service that uses Go templates. It will query the Consul service, and it will fill up the template. I can even show you the template. See? This will create a hosts file, and it will be injected into the DNS mask, which will do the load balancing automatically for you. But you won't have the health checks. But since this is for development environment, I don't recommend doing this in production. In production, like I said, I recommend running Kubernetes, which it has platform called SkyDNS, which does this for you. So, okay, service is up. Sometimes this is buggy. Where is it? Sorry. Okay. You have to do some configuration here. This is a Kong user interface. This is unofficial. I recommend you use it to learn how Kong works. What happened? Help? Wasn't me. Okay. Thank you. Okay. Now, where did I put the browser? Okay, here it is. So, I'm going to create an API called authentication. No request host. Kong has a limitation. It doesn't allow you to have multiple upstream paths per request host. It will be addressed in the next version. So, I'm going to put the request path to /login to the upstream URL authentication service, which is, oh, by the way, I forgot to show you Consul. This is Consul. As you can see, you have services. You even have a key value store, which can be fetched from the Spring Boot offers you the Spring Boot starter for the cloud to fetch configuration from here. You can just create foo bar, and you can just Spring will query this, and it will retrieve the configurations for you. This I won't go into many details. This is for another talk. So, as you can see, book service. Okay, looks good. Service health check. Okay. This is for the authentication service. Like it's passing, is making requests to the IP, and it's passing, which means when the template's generated, if this is not in green, it will not generate for this host. So for the authentication service, and we want to preserve the host because of the redirect. We don't want the client to show up, the redirect to authentication service, to literally the string. And for the book service, request back, books, stream URL, results. Okay. Now we have two APIs. Now, we need to enable the plugin. I created a plugin specifically for this presentation, which is the Redis session. Let me just get here my notes pre-configured. We need to choose the API for the books, Redis host, Redis. Cookie name is named session. And this is the session prefix where it needs to be fetched from Redis. From the hash. This is the hash that will contain this key with the jot. So I created. Okay, looks good to me. Now this is the part that I pray that this doesn't bug now. Sorry. /login. Okay. Just clear the cookies. Okay, cookies are clear. So, foo bar. Okay, it's not doing anything, but if I go to books, I have the books endpoint available. And I created a new endpoint to show you the principal that's injected through the token. See? Which means when the request reaches the book service, it's just there. It's in the authorization header. I just have to verify the signature, inflate the JSON, retrieve the principal, inflate that principal to a Java object which contains the user, validate the user, its credentials, and this is pretty much how microservices, in my opinion, should be integrated. Okay, coming up on the final part, I have some tips for you. When generating Docker images, avoid using the Ubuntu image. Ubuntu image itself, just raw, has around 500 megabytes, which is a lot. I recommend using the Alpine image, which is like 86 megabytes the image. Alpine is essentially a busy box with some alternatives to glibc, so you can compile stuff. It makes your containers very much lightweight. I recently saw in the community some Ubuntu and CentOS images that had like 3 gigabytes, meaning, okay, if I have a distributed application, both in the US and Europe, it's 3 gigabytes for each deploy. Imagine that on a Kubernetes cluster where you don't know where the images are going to be hosted. This is the philosophy that microservices, you should follow it. Just do one thing, do it well. This is the startup philosophy. If your microservice is doing too much stuff, you should start thinking of refine it a bit more. Creating, okay, imagine you have a book service with ratings for those books. Perhaps it makes sense to have, for example, a rating service in a new service using a graph database that interconnects, for example, the ratings from all the users. You can use those for tracking. This is a main mistake I see when creating Docker images. I see many people installing OpenSSH. Don't do that. You can just do Docker attach to that process, or Docker exec/bin/bash, and you're attached to it. You don't need to install OpenSSH. It will just add more complexity to the Docker. About database sharing, I'm developing an application which shares the same database but has different schemas. It has different schemas because the services, two different services performing queries on the same database, usually it's not a good idea. You'll probably end up with some inconsistency in the data if the locking is not well handled, and you don't want that. This is my recommendation to use for production. Use Kubernetes or Amazon Elastic Container Service. If you're 99% sure that if you have a startup, you're starting up your business, I'm 99% sure that you're going to use Amazon Elastic Container Service. I don't have time to demonstrate Elastic Container Service. And last but not least, use Swagger. Here in Nelson's presentation, well, Swagger, don't abuse on Swagger, but imagine you have two teams developing two services that are going to interconnect to each other. To avoid, to make it parallelable, to make it parallel work, you define a contract, a basic contract. And in my opinion, don't rely on the code generator from Swagger. For example, in the Python client code generator, I detected a bug where it didn't handle redirections to another endpoint that returns a JSON. Doesn't handle the deserialization in those cases. It's an open bug, and it will be fixed sometime. So, hope you guys enjoyed it. I hope you guys learned a lot. Questions? No questions?
Hello. So, great presentation. Thank you.
Thank you.
My first question is, there is a way to provisioning that kind of configuration that you did on Kong automatically, or do we need to set up using the UI each time we build the
You can do curl requests. Kong uses either Postgres database or Cassandra database to store its data. They recommend Cassandra because it's faster and it's easier to distribute. But you can put an instance up and just perform curl requests to the conch to configure. I just use the UI so I can be more speedier and show you how it works.
And Consul also have an API to do that kind of stuff?
Consul has, but I'd rather leave the Consul API for the microservices. The gateway should be, how should I say, should be just in the DNS part. You should typically should have a DNS part to do the service configuration, but I'd leave the API gateway alone if I were you. Leave it standalone.
Okay, so and my second question is, there is a method or a procedure to avoid the microservice L when you are deploying a new version that, for example, break the signature of a given API? Do you recommend API service or another kind of method to avoid that kind of problems?
So you're talking about, for example, deploying V2, right? And you want to replace. What I recommend when you're deploying new versions is put those instances up, but don't add them to service discovery and put them into a different namespace. For example, with the timestamp of the deployment. Then you go into the API gateway, change it to that DNS, and when the old instances don't have requests, shut them down. There are tools that help you do that, but this is for me the simple solution. It's just put it up on the side, redirect the requests to there, and let the other ones just gracefully die. It's okay, it's a bit messy, but well, it's the cost of the distributed computing. If anybody wants the source code? Was the code that bad? Okay, guess we're done. Can I? Okay. So, thank you all for being in this presentation. I hope I enlightened you all about my opinionated view about microservices. Well, thank you.